Good afternoon, everyone. Coming to you straight from Arizona. It's currently the 1st of January, 2025. Recording this at 11:30 Arizona time, so 1:30 Montreal time. This is the English companion to the French video posted yesterday. I don't have a script, so for those of you who watched twice, first off, I'm sorry you have to sit through 2 hours of Mr. Benton. And secondly, there will not be too much cohesion or overlap between the two. I have no scripts. I can just say what I say. There might be overlap, there might not be. That will be to be seen. I'll try to have all the information possible in both videos. Sweet, let's just get started. Hello, everyone. So I want to start off with the course plan for today, for the METAR and TAF course. We have a little introduction. What's a meter? What's how to read a meter? What's a TAF? How to read a TAF? And some examples throughout. And that's what most of this course is going to be, is examples, because that's the only way to learn, really. Let's start off with a little introduction. So I want to let everyone know that in aviation, everything is about planning. You have to plan what's happening, where, why, whatever. A big part of that planning comes down to the weather. The weather is one of the most unforeseeable and important aspects in aviation, the things you can't foresee and that affect you the most, right? I always like to say about the weather that if you respect it, it respects you. Let's give an example. If you respect the weather, what can happen is that you can have fantastic flights with good temperature inside the cockpit. You can go super fast with good tailwind, so good gas. You can land and take off on perfect runways every time. You can have just a great time, and your oil will work perfectly and have enough and good temperatures, whatever it might be. If you don't respect the weather, the following things can happen. You can start getting rain during your flight, which can affect your electronics. You can have ice in your carburetor. You can land on ice or take off on ice. Most importantly, you can die. This is a big thing in aviation. You can die if you make these types of mistakes. So that's why it's important to plan. Pilots, we need to read and predict the weather constantly. As I said, it's one of the most important and impactful things in a flight. So you need to know what to do about it and how to read it and what's gonna be happening. So internationally, we use two systems: the METAR. I always say it in French, the METAR. That makes sense, right? But when I'm saying in English, I really never know what to say. I say meter sometimes, METAR. I think both are kind of gross, so I'm gonna be switching interchangeably between the two, and the TAF. Sweet. Let's go straight into the METAR. So METAR stands for Meteorological Aerodrome Report, right? In the name, but I'll still go through the definition. The current weather at a specific location. And when I say current, I mean current. If let's say it's 3 degrees outside, and we know that in like 20 minutes it's going to be 5 degrees because the sun's coming up, we're not saying 5 degrees. We're saying 3 degrees. If it changes, we're going to change the METAR, right? It's published by some airports. Sorry, by airports and some aerodromes. For those who don't know the difference between an airport and an aerodrome, I'll try to make it pretty quick. An airport is essentially like official. Montreal has the airport. St. Hubert has the airport. There's a tower. There's often like safety stuff around, like fire trucks and whatnot. It's official. And an aerodrome is less official. Essentially, if you have a friend that has a piece of runway behind their house and then like a little house, a little like keep the plane, that's an aerodrome. It's whatever you can land on. All airports are aerodromes. Not all aerodromes are airports. Essentially, saying that they're published by airports and some aerodromes just means it's pretty official, but even some non-official stuff can publish it without too much issue. Sweet. It's used by pilots to plan a flight. If you're about to go flying and you want to know what is the current weather, right? Is there ice on the runway? Is it's raining right now? I'm gonna look at this and to plan my flight. And they look like gibberish. We'll get to some examples later. But this is all actually to increase legibility, paradoxically enough. It's to have less information crowding up your view and to be able to read it faster. We'll look at some examples, and for me, I'm able to read this like it's just pure English. It's actually pretty difficult for me to translate it from my brain to any amount of speaking because it makes so much sense to me, and the syntax is kind of backwards. But we'll get to it, and you guys are going to be able to understand it without issue. Let's go on to how to read a METAR. I'm kind of covering some stuff here. I'm not actually covering anything, but I'm almost covering the word win info, but there's nothing where my camera is right now. Sweet. So, METARs are always just blocks of information, right? And they're always in the same order. There could be some missing, for example, but they're never going to, if that makes sense. Let's start off with the order here. So it'll always start off with the name of the report, whether it be METAR, ELWIS, SPECI. We're gonna get into those slightly later, but it's 99% of the time gonna say METAR on it. Next, we have the station identifier. So I put the example of CYHU. CYHU is the St. Hubert Airport, right? In Canada, every airport starts with C and often Y afterwards. Um, so every airport has its own name. We give a name to every airport. Montreal Airport is CYUL. Saint Jean is CYJN. Quebec is CYQB. Trois-Rivières is CYRQ. You get the idea, right? So it's the station identifier, the place that makes the METAR. METARs come from aerodromes or airports, so that's where we put them. Next, we put the date and the time of the observation. The time is stated in Zulu. We're gonna get to that later, but it's normal that it doesn't make sense with what you're used to. It might say it was published at 8 p.m. when for you it's like 3 p.m., which doesn't make sense. We'll get to that. Next, we have the wind info with variation if needed. We'll get to that. Visibility and with I would wish with visual runway range if needed. We'll once again get to that. It gives the current weather. When we say weather, we mean like is it raining, is it snowing? That's what we mean when we say current weather. There might not be current weather. Condition of the sky with vertical visibility if needed. Next, we have the temperature and dew point. I'm not going to get into dew point too extensively today, but I'll try to give a little run through. Next, you have the altimeter setting. That's really for pilots. That doesn't affect the average person in their day-to-day life, but it's interesting to know. We'll get into it a bit later. We have the recent weather and or wind shear if needed. These are pretty rare to be seen, but it can be useful, right? Like for example, one of the examples we're having later is it'll say it was recently freezing rain, so that's important to know because there might be like ice on the ground still. And next we have the remarks. Remarks can just be miscellaneous things. Sometimes it's cloud opacity, sea level pressure, whatever else they can fit in there. If it's raining frogs, raining frogs. Sweet. Before going into examples, let's actually look at a bit of useful info here. So what I have here, all of this is in the PowerPoint that I've put on Google Drive and also in the Transport Canada AIM and weather manual. I forgot the exact name, but I put it all in the Google Drive, and it should all be available to everyone. These are the qualifiers for how to read weather properly. Uh, on the on the far left here, we have the qualifiers for the weather, and then next to it we have the weather phenomena. So the qualifier for the weather, it could be blowing, for example, drifting, partial, and that doesn't make sense on its own. But then if you put it with the one of the phenomena, it makes sense, right? For example, blowing snow, right, or partial smoke. Um, on the very left of the screen here, we have the intensity or proximity. That will be with a minus, nothing, or a plus. Minus being light, nothing being moderate, and a plus being heavy. We'll get to some examples of that, and it'll make a lot of sense. Next here we have. By the way, I'm not expecting anyone to memorize this for now. It's useful to know, and once again, you can consult this PowerPoint or um, the TC AIM whenever you want. It's in the Google Drive. Next, we have some cloud abbreviations. I'm sorry, I'm kind of covering the words here, but essentially, clouds. Every cloud is its own type of thing. They're made differently based on multiple factors. So we give them little names. And these names can be shortened to 2 letters, which makes things easier for legibility once again. So here we have CB being a cumulonimbus, TCU towering cumulus, ST stratus, SF stratus fractus. For example, we'll get into that very, very lightly in a bit. We're getting into a lot of stuff later in this video. Here we have qualifiers for the sky. So what we do is we split up the sky into 8 octets, we call them. And octets is essentially eighths of the sky, and that's what the sky is, right? If the sky is 4/8 covered, we can say here that says scattered, so we call that scattered clouds. It's essentially just how much cloud there is. I never memorized the octets. You don't really need to unless you're really doing it for some reason. Um, I've never had to keep it in mind. They might have it in exams. I haven't even seen that. All I look at really is that I know that if it says broken or overcast, I can't go fly. That's all I know, right? Sky clear, few, or scattered, I can fly. That's all I really care for. But it's still nice to know, is it going to be really cloudy today or kind of cloudy? Real life example here. I went to the Grand Canyon the other day, and if you go on like Apple Maps or whatever, it'll just say like, sorry, Apple Weather, it'll just say like, oh, it's cloudy today. And my parents were there for that, and I looked, and it said for the it had said the weather was currently with scattered clouds. And I said, "Oh, that's still going to be pretty light. It's only 4 octets, right?" And we got there, and we got there were clouds, but it was still a beautiful day. Most of the sky was still visible, so I was able to use this to my advantage. Um, so let's go straight into some examples here. So I have my iPad here. There might be a little with it, like with some recognition for some reason. This is new software. I'll try it out. It should be working. It worked for the other video. So let's go with this example here. I took this example off of yesterday for the Montreal airport. So this is like a real life thing. It's not made for an example. It's just the first thing I found. Cool. So let's go through this together. METAR. That's the name of it. This is a meter. Cool. CYUL. I mentioned that earlier, but that means the Montreal airport. So this meter was taken at the Montreal airport. Cool. So if we go back to our order here, I hope you guys can see it on the screen. Next, it says date and time of occurrence. So that's what these numbers are. What does that mean? There's tons. It's too many numbers to have a date and time in there. Let me explain. So this means the 31st day of the month at 22 Zulu. What does that mean? So as pilots, or in aviation, we take into account, we assume that a pilot knows what day of the month it is. Oh, well, sorry, what month it is. So we put the day of the month only. That's all you need to know. We put the minimum amount of information. And then we put 22 Zulu. Um, in aviation, we use 24-hour time and not 12-hour time. There's no AM, PM. It's all just 24. But you guys are used to that, in Quebec. Um, I guess I have a little announcement that I this thing for free for too long. Uh, essentially, I took this measurement at like 2 p.m. my time, ish. So why is it saying 10? So Zulu time is actually, we call it Greenwich time, Universal Standard Time, Universal Coordinated Time. Um, so in piloting, you don't want to say all the time zones. Oh, it's 3 p.m. It's 3 p.m. for me. It's 1 a.m. for me. Whatever. We say everything UTC time, and the time it is in London right now. So when I took this measurement, it was the 31st day of the month and 10 p.m. in London. For you guys, time of year because of daylight savings, uh, it's -5 to get your hour. So this was taken at 5 p.m. your time, and during the summer it's 4 hours. So you kind of get an idea. Sweet. So this was taken on the 31st day of the month at 5 p.m. for you guys' time. Next here we have the wind information. So the wind information is always split into three, or into two, sorry, and sometimes three. We take the first three numbers here, 0, 5, 0. That would be our degrees. Degrees being direction, not temperature, of course. And the next two numbers, 0, 3, is the speed. The speed we say at knots. Knots is a unit of measurement for speed. We could say meters per second, whatever. We use knots. Knot technically is 1 nautical mile per hour. Fun fact. So what does that mean if it's going 0, 5, 0 at 3? Let me explain. Uh, Let me draw a little circle here. This is the Earth. North Pole, South Pole, cool. Uh, let's say I'm looking at the North Pole. I'm here. I'm looking forward. That means I'm looking at 0, 0, 0 degrees, right? Earth is 360 degrees. We're looking at 0, 0, 0. Um, here would be 180 degrees. You get the idea. So if the wind is blowing at 050 degrees, that means it would be blowing more or less from here. From, right? That's the important thing with METARs. It's where the wind is coming from. And the speed at which it's coming from would be 3 knots. Cool. Letting you guys know 3 knots is very low. It's you barely feel that. Great. Next, let's get to here to the visibility. 15 SM. What does that mean? Really simple. 15 statute miles. What is a statute mile? It's essentially a normal mile. It's a non-nautical mile. It's an Earth mile, as some could say it. So if we're saying 40 miles an hour, that's what a mile is. 15 statute miles. That's how far we can see without the air itself obscuring our view. Sweet. And now here we have 3 cloud indicators. We saw them earlier in our graph, actually, in our PowerPoint here. Yes, right here. So we see few clouds, broken clouds. These are layers of clouds, right? And we have the 3 numbers afterwards. This tells us the height. But you might be thinking 40 feet. That's not very high. 250 feet. That's not very high. To aid with legibility, to make as little information as possible, and as easier to comprehend, you just add 2 zeros afterwards, right? So if it says few at 040, that just means 4,000 feet. So there are a few clouds at 4,000 feet. There's a broken layer of clouds at 13,000 feet. And there's another broken layer of clouds at 25,000 feet. I hope that makes sense for everyone. We'll see a lot of these in the examples later on. This next section here is temperature. Temperature is always 2 numbers on the left side and a couple numbers on the right side. Oh, a couple numbers on the left, a couple numbers on the right. The numbers on the left is always the current temperature. Why is my pen not working? Hello? Pen? Did I go into... I guess my pen's not working anymore. I'm going to try to troubleshoot that real quick. No matter. I can try to... Oh, there we are. We're back. The numbers on the left is always the temperature, and the numbers on the right is the dew point, right? So in this case, we have a temperature of 3 degrees Celsius and a dew point of minus 1 degrees Celsius. What is a dew point? Very quickly, it is the temperature at which water vapor can condense. So if these numbers are very close, it means clouds will be pretty low, because you only have to go up a tiny bit for it to be cold enough to make a cloud. Once again, I guess I'm having the visor free thing here. And if they're far apart away, that means it's a very long distance for the clouds to appear. For example, in Arizona right now, there are not a lot of clouds. Often when I check the METAR for where I am, it'll say temperature 25 degrees, and then the dew point is -5, -10. So the clouds are very, very, very high up. Cool. Next, we have the altimeter setting. All this means is that for a pilot, if I'm about to go flying, I have to set my altimeter to 29.81 inches of mercury. Hg means mercury. That will basically say if I'm at 10,000 feet, for example, my altimeter will actually read 10,000 feet. Pressure changes. It's a unit of measurement. Sweet. Now we're in the remarks section. I said the remarks section can kind of be whatever, and here is a bit of that whatever. We're seeing SC1, AC5, CI1. What does that mean? That is a layers of clouds. So here, SC1 is actually we can look at our cloud diagram down here. SC1 was stratocumulus, and 1, what does that mean? That's the octets. We mentioned the eighths of the sky. That means there's stratocumulus at 1/8 of the sky. It's covering up 1/8 of the sky. Then we have altocumulus at 5 octets of the sky. And then we have cirrus at 1 octet of the sky. Cool. And then the CITR, that's, for those who saw the French video, I didn't know at that point. Now I looked it up. It's very simple. Traces of cirrus throughout. Cool. Lastly, we have C099. Honestly, the most useless bit of information for any pilot I know. I don't know anybody who uses it on a daily basis or ever really, but if you want to know, it's another way of measuring pressure. What you do here is if there isn't a 7 or 8 or 9 at the first number, you add 10 in the front, and so that's 1009.9 millibars. I'm gonna throw out a number. Let's say it said 953. So now that's 995.3 millibars. Doesn't matter too much. If this is fun information to know, but I've never used it. So this one is a bit simpler. It's an LWIS, right? It doesn't say METAR, it says LWIS. What does that mean? LWIS is Limited Weather Information System. Essentially, it doesn't give as much information as a METAR, but it still gives the information it can. Um, for example, this would be for smaller airports or just weather stations that aren't for aviation necessarily. Let's read this one before we get into anything else. LWIS, so Limited Weather Information System, at CYLA. No idea what airport that is. It could be a small city for all I know. 29 2000. What does that mean? 29th day of the month at 20 Zulu. So once again, 20 Zulu for you guys is 3 p.m. So this was published on the 29th day of the month at 3 p.m. Montreal time. Auto, what does this mean? It means it's an automatic message. This is not a human analyzing the weather. This is just a robot. It takes a little measurement and says, this is what it is. We have the wind here. 310 at 6 knots. That was the grossest 6 I've ever drawn. Meaning the wind is coming at 310 degrees at 6 knots of intensity. We have the temperature here. We have, that was not an arrow, but you'll pretend it is. We have 0 degrees Celsius temperature, and the dew point is -2 degrees Celsius. So it's a bit chilly outside. And lastly, we have the altimeter setting, 29.26 inches mercury. Sweet. Hope that makes sense for everyone. I think we'll just pass on to the next one. Actually, no, I'll give you a little information about the LWIS. LWISs are used. I use them personally at the Saint Jean Airport where I fly. There's an LWIS reader like pretty close to the city of Saint Jean, but it doesn't give me all the information I need. Right? When I go flying, I have to know where the clouds are and what the visibility is, at least. And this doesn't give me that, but it gives me more accurate information on the winds. So I supplement this information with the information of the METAR from um, Saint Jean, or no, not Saint Jean, sorry, Saint Hubert or Montreal. I guess this visor thing doesn't like that I've been using it. Um, let's continue. There's another example. Do I have another example after this? I have 2 other examples. That's how you learn, guys. Just example after example after example. So, um, let's read this together. I think I can go a bit faster. METAR. This is a METAR, not an LWIS, not a SPECI. It's a meter. At CYWG, that is Winnipeg Airport. Published on the 17th day of the month at 8 p.m. Zulu. So, if you remember, depending on what month this is, let's say it's the 17th day of January. This means 5 p.m. for you guys in Montreal. Okay, now what's up with this with the wind? It's way too many numbers. What does this mean? So pretty simply, this means it's our classic 300 at 15. So 300 degrees at 15 knots, gusting 25 knots. Um, so normally the wind is 300 at 15, but sometimes it'll go a bit stronger at 25 here and there. That's what a gust is. Sweet. On to visibility. Here we have 3/4 of a mile. So visibility is less than a mile. And because it is less than 1 mile, we can have this extra information here. The runway range. The visual runway range. It's hard to say, but the slides earlier. Essentially just tells you the distance at which you can see the runway. I've never used it or seen it, but it can be useful for other more experienced pilots. Essentially what this is saying is on runway 35, this airport probably has a runway that's runway 35. The distance is 4,000 feet, and you can see D here, which is deteriorating, so it's getting worse with time. Next line here we have light snow. That's what I was mentioning earlier. Minus means light, and then SN we saw here means snow. So light snow. And then BLSN, we saw that earlier. I actually used that as an example. Blowing snow. That's just things that are happening, right? There's a bit of light snow and then there's blowing snow because of the gust of wind. Now we're getting to the section. There's two layers of clouds here. We can see there's a broken layer of clouds at 800 feet, an overcast layer of clouds at 4,000 feet. How do I know that? Once again, I just add two little zeros to 800 to the 008 and 040. Cool. So that tells me there's two layers of clouds. Um, we have the temperature at this point. So this minus 5 degrees Celsius, and the dew point is minus 8 degrees Celsius. For you guys, really ignore the dew point. If you're reading this just to know the temperature, just look at the minus 5. That's all you need to know. Next, here we have the altimeter setting, 2992 inches of mercury. Not useful to you guys, but it's still useful to know. Here is the thing I mentioned earlier. Means recent. There was freezing rain. So a few hours ago, maybe, or maybe just a couple minutes ago, there was freezing rain, so there might still be ice on the ground. This next one here is wind shear. Wind shear means sometimes the wind changes directions abruptly in the air. So what that can mean is if you're coming to land, you could be pushed down or thrown up, which are two terrible things. So it's important to know. So they're saying there's wind shear on runway 36. That's what that's saying right here. Lastly, the remark section. We have that right here. So I'm assuming that's SF. Practice at 5 octets. It's kind of blurry, but you can see it. And then nimbostratus is at 3 octets. Once again, we have the sea level pressure. 134 would mean, what am I talking about? 1013.4 millibars. Perfect. I hope that's pretty clear for everyone. One more example, and then we're done with METARs. Cool. This one's I got these from different sources, and I think they copied off each other because they're very similar. So let's just go through it a bit quicker, okay? So METAR XC, no idea what airport that is. 29th day of the month at 8 p.m. Zulu, 5 p.m. your time. CCA. This means correction. I forgot what the actual acronym stands for, but this is a correction to an earlier METAR. Either there was a mistake or something changed. The wind is 300 at 15 knots, gusting 25 knots. So, wind is normally 15 knots, and it gets stronger sometimes for 25 knots. What is this thing doing in my face? Visibility here, you can see it under the little overlay, is 3/4 of a mile. Because it's less than a mile, once again, we can say runway 33 visibility is, say runway range is 4,000 feet, which is here. It's mentioned that there's light rain, and BR is fog. So actually, I'll go here real quick. If we look, a lot of these words are in French, or taken from French. Obviously, a lot of these are in English. SN snow, RA rain, DZ drizzle. But a lot of these are from French. BR, brume, right? But we say mist or fog or FG fog. Sorry. So you have to learn kind of both, but it's useful to be francophone in this situation. So BR is mist. Now we're getting into the cloud section. There's broken clouds at 800 feet and overcast clouds at 4,000 feet. Remember, we just add 2 zeros. Now we're into the temperature section. If you guys remember, on the left is the temperature, 21 degrees Celsius, and on the right, it's the dew point, 19 degrees Celsius. That's why the clouds are so low. The dew point and temperature are pretty close together. Sweet. Altimeter 2992. We said that's inches of mercury. The WS here, that's wind shear on runway 33, as we mentioned earlier. It means the wind is changing directions abruptly, which can be dangerous. Into the remarks here, we have that the layer of clouds at 800 feet is a stratofractus at 5 octets, and the overcast clouds at 4 are nimbostratus at 3 octets. And that can explain the rain. Nimbo means to rain, so that can make sense why there's light rain. Sweet. Here there's a section that says vis NW 3/8. What that means is that the visibility all around you isn't equal. If you look northwest, your visibility is 3/8 of a mile, which is much lower than 3/4. Perfect. And then next is the sea level pressure 134. So as we mentioned earlier, that's the same sea level pressure, 13.4 millibars. And here we have a density altitude of 2,500 feet. Really don't worry about that. We'll get into density altitude at some other point in the future, but it's information that can be given to you. Perfect. So let's continue with my slides here. So a TAF stands for Terminal Area Forecast, and it's actually a way to read the forecasted weather. It's published almost exclusively by airports because it's a more like difficult thing to make, I suppose. You rarely see TAFs for aerodromes. It's used to plan flights in advance, so that could be hours before, days, or a day before. Normally, TAFs are good for a 24-hour period, so they won't tell you a week in advance, but they can tell you a day in advance what's happening, ish. And we'll look at the info per hour is very minimal, as to maximize the amount of hours, the number of hours shown. Cool. So let's see how to read a TAF. It's a pretty similar structure to the METAR, with obviously more because there's more hours to be mentioned, right? I forgot. I'm so sorry. METARs are published every hour, and TAFs are published every, I want to say, 6 or 8 hours. I believe it's 8. I'll have to I guess check for that, but it's either 6 or 8 hours. So a METAR is every hour. Cool. Um, it starts off with the name of the report. So it'll say TAF or AMD. Often TAF, AMD just means amendment to TAF. So we're changing something before the next TAF is published. Um, Great. Here we have the place, date, and time, and the coverage period. It's all in one line to give as much information as possible, much space as possible for the rest. The auto identifier is what I mentioned earlier. It just means it's not made by a human. And I think we have an example of that in one of my examples. Winds, and then if there's wind shear, we'll mention that there. Then we'll see the visibility. The thing is with TAFs is the visibility will never be more than 6. It's just the way it's measured. It can't be more than 6, and it's actually only valid. A TAF is only valid for a 6 mile radius of the airport. So often it'll say like it's 3 mile visibility, 4 miles, 5, and then if it's like 7 or 10 or 15, you'll just say it'll just say P6, so more than 6 miles. That's all you get. It'll tell you significant weather. Once again, weather just means if it's raining, snowing, whatever. It'll tell you the sky condition. That's the thing we saw earlier with the octets of the sky if needed. And then let's say it'll maybe rain at 2 p.m. So it'll say there's like prob 30 of rain at 2 p.m., for example. It'll tell you changes in forecast and time if needed. And then lastly, the remarks, which is once again miscellaneous info, stuff they just want to tell you to let you know that they didn't have room for in the rest of it. Let's get right back into these examples here. This TAF, I took it at the same time as the METAR for Montreal. So this is from yesterday, my time. Let's start reading, right? Here we have the identifier, TAF. Cool. The station identifier, CYUL, that's Montreal, Pierre-Éliott Trudeau Airport. And this was published on the 31st day of the month at 2040 Zulu. So at 8:40 p.m. Zulu. So that means 5:40 p.m. 3:40 p.m. your time. Cool. Let's start reading. From a period of basically for the whole day. On the 31st day at 21 o'clock to the first day at 24 o'clock, so at midnight, this is how long, what it's good for and what it's expecting to forecast for. And generally, without, unless further notice, I suppose, winds will be 240 at 6 knots. That's the base wind for the day. Once again, that's 240 degrees at 6 knots of strength. Visibility, as we said, plus 6 miles, so just more than 6 miles. That's all we get to know. With broken clouds at 4,000 feet. Great. On the 31st day at 21 o'clock until the 31st day at 22 o'clock, that's what these mean, right? For first two numbers is the day, last two numbers is the hour. There'll be variable wind at 3 knots. What that means is sometimes when the speed of the wind is very low, let's say 3, 2, or 1 knot, It's actually difficult to tell where the wind's coming from, and it doesn't really come from anywhere specific. It kind of just like small gusts here and there. So that's what variable means at 3 knots. It's not a specific position, and it's very low winds. Cool. So from the 31st day at 23 o'clock onwards, that's what the FM means from. Um, the wind will be at 050 at 8 knots, visibility more than 6 miles, a few clouds at 3,000 feet, and broken clouds at 10,000 feet. Once again, we add two zeros to broken, or to the numbers to know the height of the clouds. And lastly, here we have overcast clouds at 20,000 feet. Fantastic. Which is on the first day at 3 until the first day at 5. The wind is going to change at 140 at 12 knots. Cool. See, that's what these numbers mean. It's mainly English. FM from, BECM, G becoming, makes sense, right? Great. Let's see on the from the first day of the month. Well, starting on the first day of the month at 11, the wind's gonna be 040 at 12. Visibility 6 miles, and overcast clouds at 7,000 feet. From the first day of the month at 13 o'clock, the wind will be 140 at 12. Once again, that doesn't change. Visibility is going to go down to 3 miles. There's going to be light rain and snow, and overcast at 1,500 feet, so 1,500. What's a good thing to say in English? You can just say this. You just say 100 after the word. So it says, if it says 100 feet, 1,500 feet, you get the idea. As of the first day at 15 o'clock, winds will be 050 at 12, gusting 22. What does that mean again? That means that the winds will be blowing at 050 degrees at 12 knots, and then it will get stronger. It will go at 22 knots from time to time. We're expecting it to, at least. Visibility is going to be 2 miles with light rain and snow. With we're expecting mist with overcast skies at 800 feet. This is about 11 a.m. for you guys as I'm recording this. So this is a couple hours ago. I'm assuming you guys are having pretty bad weather currently, if I'm to believe this. And then as of 18 o'clock on the first day, it's going to be 040 at 12, gusting 22. Visibility is going to be 1.5 miles, so not very big at all. With light snow and rain, with mist and overcast skies at 500 feet. Great. We read this together. It's pretty easy. We have the remarks that the next forecast is going to be by on the first day of the month at midnight Zulu. Great. So by this time, there's already been like multiple forecasts projected for Montreal since this. Okay, has been used for 2 hours. Thank you, Visor. So this is just in the moment, right? You always want to use the most recent TAF, the most recent METAR. It's the most accurate. Let's get to another example here. I guess I forgot to erase this one from the other video. Sorry, guys. Great. So let's get through this. It'll be quick. We got the idea. What I want to mention is that normally TAFs are organized like this, in the way that they're like vertically organized for each hour. In the examples I have, they're not, but almost every time I've ever seen a TAF, they are. So it's going to be more difficult in the examples than in real life. So have no worries for that. Perfect. So, this is a time. No idea where QM is. Published on the 29th day of the month at 11:45 Zulu. This is valid from the 29th at 12 to the 30th at 12. Winds for this time period will be 240 at 10 knots, gusting 25 knots. Wind shear on wind wave 11. No, wind shear at 11 degrees. What am I talking about? I think I said one in the other video. I'm not. Wind shear at more or less 11 degrees. 270 degrees. Sorry, alternating between 11 and 270. I'm going crazy here. At 50 knots, so that's gonna be pretty strong wind shear. Visibility is gonna be 3 miles with light snow and broken clouds at 1,000 feet. Overcast clouds at 4,000 feet here. We have temporarily after this from the 29th at 18 o'clock to the 30th at 1 o'clock. Visibility is going to be, it doesn't say 11 divided by 2. It says 1.5 statute miles. It's a bit confusing. Normally it's written a lot better. We saw it here. There's more of a gap between the ones normally. With light snow and blowing snow with broken clouds at 800 feet with a sorry 800 feet period. Normally it's a line break. I'm just reading continually. Prop here, new line. Um, there's a 30% probability that on the 29th to 20th, the 29th to 22 o'clock, visibility is going to be half a mile with and a vertical visibility of 500 feet. That's what VV means here. If any of you guys are confused with any of the terms I'm using, all of these are available again, once again in the Google Drive, in the PowerPoint, um, or the TC AIM. It has all the information you need. No pilot is expected to remember all of these terms. I forget some of these myself. So you have to be able to know where to find them. That's what it's important about being a pilot. Sweet, let's continue on to the next line here. From the 30th day at 0130, so 1:30 in the morning, uh, wind is going to be 280 at 10 knots, 5 miles of visibility, with light snow, broken clouds at 2,000 feet, which are becoming on the 30th at 6 to the 30th at 8, with zero wind. When we say 0 knots and zero wind, that just means like it's too light to even measure. It's just barely anything. With zero wind, more than visibility, clear skies. So it's going to become a fantastic day. And here we have a little remark. Next forecast by the 28th at 18 Zulu. Sweet. You'll notice there's a lot of overlap between these. Right? Like it'll say next forecast by 18 Zulu, but we're talking about 18 Zulu in this, right? Or even before. Yeah, it's to know. You just want to use the recent one. They talk about the same amount of info pretty often. They just go a bit further every time. You just want to use the most recent TAF. Sweet. Next example here. This one's a big one, but we'll get through it together. We're able to. Just jump straight in, okay? Is it the same? Yeah, it's honestly pretty similar to the one we just saw. I'll go through it pretty fast still. The TAF as CYXC, no idea where CYXC is, on the 28th day of the month at 11:39 Zulu is when it was published. This is valid from the 20th to 12th to 29th to 12. Winds are 240 at 10 with gusting 25 knots, so winds 240 degrees, 10 knots, and then sometimes it'll gust up to 25 knots. Wind shear between 11 degrees and 270 degrees at 50 knots. Visibility of 3 miles with light snow, broken clouds at 1,000 feet, overcast clouds at 4,000 feet. Temperature 28th at 18th to 29th at 1. Visibility is going to be 1.5 miles with light snow and blowing snow, broken clouds at 800 feet. There'll be a probability of 30% that from the 28th to 20 to the 28th to 22 o'clock, visibility is going to be half a mile with snow and a vertical visibility of 500 feet. From the 29th at 1:30 in the morning, snow will be 280 at 10 knots with 5 miles of visibility, and light snow with broken clouds at 2,000 feet, which are becoming the 20. The weather is also on the 29th at 6 to 29th at 8. It's going to be clear with zero wind, or expected zero wind, more than 6 miles of visibility with a clear sky. Remark here is going to be about 28th at 18 Zulu. Great, I think that made sense. To all those who didn't get any part of that, please contact me, text me. I'm glad to re-explain any part of this. Fantastic. Let's go back to my PowerPoint here. So, I guess I'm covering my own PowerPoint. Consulting a METAR TAF. So, here's a little surprise for you guys. I want you to do some homework from now on. Now, every day that you are consulting the weather, whether you want like Apple Weather, just your whatever weather app you use, I want you guys to first and foremost use a METAR or TAF. We see that it doesn't give all the information the average person needs. It doesn't give the feels like temperature. It doesn't give humidity. But I want you guys to read as much information as you can from the METAR and TAF because it has to become a second language to you. See, I'm able to read these with very easily because I read them every single day, or at least 3 times a day, for 7 weeks straight this summer, and before that as well, right? So that's what all this into for you guys to, of course, know how to read these without issue. What you're gonna do is look up CFPS Nav Canada. We have the first link here. CFPS, welcome to CFPS. That's what I want you guys to Google. Then we'll get to this little screen. Uh, I drew my numbers kind of ugly with my mouse. I'm sorry, but I think you guys can read this. Um, First step is you're gonna be clicking on weather and NOTAM. Second step, you're gonna put in the identifier of, sorry, put in the identifier of the airport. If you guys are in Longueuil, the closest airport to all of you is by an airport. If you're in Montreal, it would be the CYUL airport. Great. Um, Lastly, well, not lastly, you're gonna uncheck all the boxes: SIGMET, AirMet, NOTAM, PIREP, or upper winds. I'm glad to explain this to you guys if you guys would want, but all the information you need is in the METAR and TAF. So just have those two checked, and then click search. After that, all the information in front of your screen is going to appear. And you know what? Let's just read this one quickly, just to get it out of the way. All right. So the METAR. The METAR at CYHU, so at St. Hubert, published on the 31st day of the month, the 22 Zulu, is an automatic message, so made by a robot. The winds are 080 at 4 knots. Visibility is 9 miles, with overcast clouds at 4,000 feet. Um, there's temperature is 3 degrees, and the dew point is -2 degrees, and with a remark that the sea level pressure is 1,010.2 millibars. You'll see when it's automatic messages like this, you often won't get what type of cloud it is. You need a human to be able to tell that. So it'll just tell you there's clouds, overcast clouds at 4,000. That's all you get to know. You might want to go into the Montreal METAR because those are made by a human being. And then we'll look at the TAF. I'll do this really quick. TAF at St. Hubert, published on the 31st day of the month at 1744 Zulu. It's valid from the 31st at 18th to the 1st at 18 o'clock Zulu. For this time, the wind is going to be 240 at 10, gusting 20 knots, more than 6 miles of visibility, with few clouds at 1,500 feet and overcast clouds at 4,000 feet. Temporarily, from 18 o'clock to 21 o'clock on the 31st, clouds will be broken at 15 and overcast at 4,000, which are going to be becoming at 31:20. Sorry, for a bit on the 31st at 20 o'clock to the 31st at 21 o'clock. Variable winds at 3 knots. From the 31st to 2300 o'clock, the winds will be 050 at 8 knots with more than 6 miles of visibility, with few clouds at 2,500 feet and broken clouds at 10,000 feet with overcast at 20,000. From 3 to 5 a.m. On the first day of the month, winds will be 040 at 12 knots. From the 11th, from 11 o'clock on the first day of the month, winds will be 040 at 12 with more than 6 miles of visibility with overcast clouds at 7,000 feet. From 13 o'clock, it'll be 040 at 13 knots, gusting 23 knots with 3 miles of visibility, light rain and snow, and overcast 1,500 feet. From 15 o'clock on the first day of the month, winds will be 050 at 13 knots, gusting 23 knots. Visibility will be 2 miles with light rain and snow, with mist, with overcast clouds at 800 feet. The remark is, it says right here, forecast based on automatic observation. It really wants to let you know that it's not a human that did this. If there's a mistake, it's not the human's fault. Next forecast by midnight, the first day of the month. Fantastic. So let's just recap what we all did today. My camera's kind of blocking my stuff here. Great. So we said that weather is absolutely vital to aviation. For everything you want to do in aviation, METARs is what can let you know the weather in this current moment at a specific station, and TAFs let you know the forecasted weather at a specific location. Both use similar codes, for example, for clouds and whatnot, but they're not identical. They use different formats because they're for different things. They can both be found on the CFPS website, as shown previously. And from now on, your homework will be to check the daily weather using the METAR and the TAF. Once again, this PowerPoint is available on the Google Drive as well as all the sources I used for this. If you have any question whatsoever, please feel free to text me on Instagram. You have all my information. It can either be in the piloting group we're using or in direct messages. I have no problems with either. If I was unclear on any of these, feel free to ask. I might make an amendment to these videos if I have time. Happy New Year to all of you. It's the 1st of January, so if I publish this today, Happy New Year to you all if you didn't watch the French video. And that about does it. I'm trying to see if I'm forgetting anything, and I don't think I am. I'll try to maybe post more videos in this next couple days. I'm not sure. I don't have anything planned, but I might have like a boost of inspiration as I often do. So with that out of the way, I think it's time to say goodbye. Have a fantastic day to you all, and once again, Happy New Year.